I have another problem today sent to me by a viewer, and it says, solve the equations x squared minus y squared equals 3 and 2x squared plus xy minus 2y squared equals 4. Use a technique because all terms are degree 2. So I wonder if these can be factored in a nice way. The first equation has a difference of squares. The second equation doesn't quite have a difference of squares, but perhaps I can solve for x squared in terms, solve for x in terms of y using one equation and use a substitution. I'm not completely sure what my first approach would be, but let's write things out and see what we can do. Right, I don't really see if this is going to factor in a nice way. It's a little bit odd that there's a different sign here, but anyway, that's I'll leave that. I think what I'll try is write x squared as 3 plus y squared. You know, this might not help so much. I mean, of course, we can make a very simple substitution there, but then that x doesn't look like it will behave nicely. Well, let's I still wonder if maybe something in the second equation can be factored in any way at all. We have x times 2x plus y minus 2y squared is equal to 4. That doesn't seem to put things in any form which is convenient. Oh, interesting. So I just did some substitutions and ended up with an equation directly for y, that y is equal to negative 2. I'm going to go back and do these again, just to make sure that I didn't make any arithmetic errors. Okay, so what I did is I kind of essentially what my first instinct was to solve for one of these two variables in terms of the other and make the substitution. What I ended up doing is solving for wait a minute. Yeah, I wrote y squared in terms of x squared. So of course I have y squared is equal to x squared minus 3. Wait, hold on. What happened to that extra factor of x then? Oh, yeah, it didn't quite work out. I have x times y. I did have a mistake. X times y is equal to negative 2. Okay, but that should still help us. So if I expand this, 2x squared plus xy minus 2x cubed plus 6 is equal to 4. So this says that xy is equal to negative 2. Okay, and so that of course means that x is equal to negative 2 over y. And I wonder if substituting that back into one of the equations helps very much. It should. Okay. Okay, so I end up with a quartic equation, but it only has even powers of y, so I can treat it like a quadratic equation. Okay, I'm assuming that we're not concerned with complex numbers here. given the level that was stated in the message to me, we're only going to worry about the real solutions. So I have y is equal to 1 or y is equal to -1, which says that x is equal to -2 or x is equal to 2. And we'll go back and check that both of these do in fact work just by substituting into the original expressions. So the original one, x squared minus y squared is equal to 3. This certainly works for both of them, right? We have 4 minus 1 or 4 minus 1. And let's look at the other expression. 2x squared plus xy minus 2y squared is equal to 4. Okay, so if I make the substitutions, here I'll have 8 minus 2 minus 2, which is in fact equal to 4. And so that's also satisfied. Yeah, so there we've got the solutions, the two possible values of x and y. X is equal to plus or minus 2, and y is equal to minus or plus 1, depending on which choice of x we make. In the message to me, it says, use a technique because all terms are degree 2. I'm not sure exactly what technique that is referring to. My only guess is that maybe you're led to believe because everything is degree 2, if you make this kind of substitution that we did, I guess I solved for y squared in terms of x squared and sub that in there, you can expect eventually to have to solve a polynomial that is of even degree with only even powers, which is exactly what happened here, right? I ended up with a 4th degree polynomial, but the only powers are even, so we can treat it like a quadratic polynomial. I think that's what this is referring to. But if the viewer happens to watch this video and has something else in mind, then feel free to leave a comment. Thanks for the submission, and thanks for watching.